Okay, let's look at the net change theorem. All right, before we do that, let's recall the fundamental theorem of calculus 2. All right, it goes like this. Integral from a to b of f of x dx is equal to capital F of b minus capital F of a, where f is any antiderivative. So maybe I should do that here, where capital F prime of x is exactly the same thing as f of x. All right, so net change theorem is just a slightly rewritten version of fundamental theorem of calculus. All right, so all we do is actually, instead of f of x, we're going to put capital F prime of x as the integrand. So we can write it this way. So we have an integral from a to b of capital F prime of x dx is equal to capital F of b minus capital F of a. All right. Then you can see that this is the integral of rate of change of this capital F function is equal to the net change. All right. So let's look at the example. It's probably easier to see an example here. All right. So if W prime of t is the rate of growth of a child in pounds per year. All right. So this is a rate of change of the child's weight in pounds per year. What does integral from 5 to 10 W prime of f of t? All right. So using the net change theorem, so we can rewrite integral from 5 to 10 of W prime of t dt is really the same thing as W of 10 minus W of 5, right? So you can see that the W of 10 is the weight of the child when he or she is 10 years old, and minus W of 5 is the weight when he or she is 5 years old. All right. So this represents the net weight gain from year 5 to year 10. All right. So this tells you how much this child gained weight from 5 years old to 10 years old. All right. Let's look at another one. If oil leaks from a tank at the rate of RT gallons per minute. So RT is a rate of change of oil leak. And what does integral from 0 to 120 RT dt represent? All right. Again, we can rewrite this guy, integral from 0 to 120 R of t dt. All right. This is going to be, I'm going to have to use the capital R of t. So capital R is the antiderivative, and plug in 120 minus the R of 0. All right. Capital R is the amount of leak after t minutes. So in this case, R of 120 is going to be amount of leak after 120 minutes. All right. Then R of 0 is the amount of leak at 0. So you can consider that to be 0. So this guy represents, I need this there, represents All right, so this is the total amount of the oil leakage in the first 120 minutes or 2 hours. All right. So this is the net change theorem. So all it says is that just rewriting a fundamental theorem of calculus 2, and we can interpret it as the integral rate of change is going to give you the net change of whatever the quantity you're looking at. All right, that's it. I hope that this was clear.